Hello students, we are solving the IB Math AAHL past paper questions and currently we are solving the IB Math AAHL May 2023 paper 1 time zone 2 past paper. Today we will be solving the second last question of this paper, that is question number 11 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlist in my channel NS Online Math Tutoring Classes. So without any further delay, let us start answering question number 11. The maximum mark is 22. It says consider the complex number u equal to negative 1 plus root 3I. So part A's question is by finding the modulus and argument of u, show that u equal to 2 times e to the power of I times 2 pi over 3. Okay, so let me start my answer from this point. First of all, we have to get the modulus. So the modulus will be the positive square root of negative 1 whole square plus root 3 whole square. Root 3 whole square is 3 and negative 1 whole square is 1. 1 plus 3 is 4. Square root of 4 is equal to 2. So the modulus is 2. See? And for the argument, so tan theta, theta is the argument, will be equal to root 3 over negative 1, which is equal to negative root 3. Therefore, theta is equal to tan inverse of negative root 3, which is equal to positive root 3. If tan theta is equal to positive root 3, taking theta to be an acute angle, what will be the value of theta? It will be pi over 3, 60 degrees. So, negative root 3, we are taking the angle from the second quadrant. It will be 2 pi over 3. Okay? So, this is 2 pi over 3. Therefore, u is equal to 2 and e to the power of I 2 pi over 3. Okay. It is shown. Subpart B. It is containing two further subparts. It is saying the first subpart I, find the smallest positive integer n such that u raised to the power of n is a real number. That means its imaginary part will be equal to 0. Okay. So let me write the B's answer over here. Subpart I, the first subpart, u raised to the power of n. Using the de Moivre's theorem, it is u raised to the power of n will be equal to 2 to the power of n and e to the power of I 2 pi n over 3. Okay, and writing this in cis form, this is equal to 2 raised to the power of n and cos 2 pi n over 3 plus I sine 2 pi n over 3. And it is said that u to the power of n will be a real number. Therefore, this part should be equal to 0. Okay. Since u to the power of n is real, therefore, sine 2 pi n over 3 should be equal to 0. Okay. And we know that sine 2 pi k equal to 0 where k belongs to any integer. Okay. So, therefore, 2 pi is there. Therefore, n over 3 is equal to k. So, n over 3 should belong to the set of integers. That means n over 3 should be an integer. Okay. And I can take n equal to 0. 0 over 3 is equal to 0 and 0 is also an integer, but they are saying n is the smallest possible positive integer. So, n cannot have a value of 0. It should be having a positive value, positive integer value. Okay, so therefore n can be equal to 0, n can be equal to 3, n can be equal to 6, n can be equal to 9. Smallest possible integer, therefore smallest, not possible, positive integer value for n is equal to 3. Okay, so this is the answer for the first subpart of subpart I, and it is saying the second subpart is saying find the value of u to the power of n when n takes the value found it in this part. That means when n is having the value of 3. So this is b I u to the power of n is equal to 2 to the power of, or I should be writing 3. In place of n, I am writing 3. So u to the power of 3 is equal to 2 to the power of 3 and cos 2 pi times 3 over 3 plus I sine 2 pi times 3 over 3, and this is equal to, therefore u cube is equal to 2 cube is 8, and these two will be getting cancelled, and cos 2 pi is 1. And these two will also get cancelled, and sine 2 pi is 0 plus 0. So this is equal to 8. So u cube is equal to 8. This is the answer for the second subpart of the subpart B. Subpart C. Consider the equation z to the power of 3 plus 5 times z squared plus 10 times c plus 12 equal to 0, or if you call this as z, it is z cube plus 5z squared plus 10z plus 12 equal to 0, where z is a complex number. It is also having two subparts. The first subpart I is saying given that u is a root of this equation, find the other roots. Because it is a cubic equation, it will be having 3 roots. Okay, so Ci, since the polynomial, the cubic polynomial is having all real coefficients, therefore, and since what was u? U was negative 1 plus root 3i. Negative 1 plus root 3i is one of the roots therefore negative 1 negative root 3i, that is the complex conjugate, will be the second root. Okay, and the third root has to be a real number. So the third root it is. Third root is real. Let it be x. Okay. So therefore, sum of the 3 roots, I'm using the sum of the roots, product of the roots property. Okay. So sum of the roots is equal to minus 1 plus root 3i plus minus 1 minus root 3i plus x. This should be equal to negative 5 over this is 1, which is equal to negative 5. Okay. And if we add these two, we see that these numbers get cancelled and it is -1 and -1. So it is -2 plus x equal to negative 5. Therefore, x is equal to negative 5 plus 2, which implies x is equal to negative 3. Okay. So therefore, the other roots are -1, negative root 3i and negative. Okay. Coming to the II. By using a suitable transformation from z to w or otherwise find the roots of the equation 1 plus 5w plus 10w square plus 12w cube equal to 0, where w is another complex number. Okay. By using a suitable transformation from z to w, just by looking at these two equations, you see the coefficients are the same. This is 1, this is 1. Then 5, 5, 10, 10, 12, 12. The numbers are the same. Over here it is z cube, but we are not having any z cube over here or any w cube. We are not having that. So how can I get rid of this z cube? Either I have to subtract, or as z cube minus z cube will be giving us 0. That also I don't want. I need the 1. So I cannot subtract. What can I do? I can divide. If I divide z cube by z cube, I will be getting 1. I will be getting this one. So let us do that division. Okay. So it is C I. It is, I'm starting with the given equation, the first one, plus 12 equal to 0, dividing the entire equation by z cube, we get z cube divided by z cube is 1. So it is 1 plus 5 times 1 over z, because z square over z cube is 1 over z, plus 10 times z over z cube is 1 over z square, plus 12 over 12 times 1 over z cube equal to 0. Okay. So now we see we are having this 1, this is 1, and then it is 5w, we are having 5 times 1 over z. Then it is 10w square. If we take w as 1 over z, then w square will be 1 over z whole square, and we are having 1 over z square. And w cube will be 1 over z cube, so we are having this 1 over z cube. Okay. Comparing the last equation is this one with the equation 1 plus 5w plus 10w square plus 12w cube equal to 0. We find w equal to 1 over z. Okay. Therefore, okay, w equal to 1 over z. Therefore, I can write the roots will be, what are the roots of z? It is, first of all, let me write the real thing. It will be just the reciprocal because w is the reciprocal of z, so the roots will also be the reciprocal. So it will be negative 1 over 3 and 1 over negative 1 plus root 3i, and you are having and 1 over negative 1 minus root 3i. Okay, if you want, you can multiply both the numerator and the denominator by negative 1 plus, just if you want to not to have an imaginary portion in the denominator, you can multiply the numerator and the denominator for this with negative 1 minus root 3i, and you will be getting rid of the imaginary portion in the denominator. But you can keep the roots as it is also. Okay. Part D. Consider the equation z square equal to 2 times complex conjugate of z, where z is a complex number and z is not equal to 0. By expressing z in the form of e plus b, I find the roots of the equation. It is containing 5 marks. Okay, I don't have much space remaining. Let me see if I can complete over here. So I am taking z to be equal to a plus bi. So z square is equal to a plus bi whole square should be equal to a square plus 2abi and plus bi whole square, that is b square and I square. I square is negative 1, so it is negative b square. Okay, and what is the complex conjugate? It is, let me draw a line over here. Okay, the complex conjugate of z is a minus bi, and they are saying, they are giving us this equation. So z square is equal to 2 times the complex conjugate of z. This implies a square plus 2abi minus b square should be equal to 2 times a minus bi, which is equal to 2a minus 2bi. Okay, fine. So therefore, now I will be equating the real and the imaginary parts. Therefore, a square minus b square should be equal to 2a, and 2ab should be equal to negative 2b. Okay, so 2b equal to negative 2b. So I am taking that one. 2ab is equal to negative 2b. I am dividing the entire equation by 2b. So this gives us e is equal to negative 1. Okay, since 2ab equal to negative 2b, a equal to negative 1. Okay, and from here, let me take this. Since a square minus b square is equal to 2a, and a is negative 1. So negative 1 whole square minus b square is equal to 2 times negative 1, or 1 minus b square is equal to negative 2, or b square is equal to 2 plus 1 is 3. Therefore, b is equal to plus minus root 3. Okay. Therefore, z is equal to minus 1 plus root 3i, or we are saying find the roots. Z is equal to minus 1 plus root 3i, or z is equal to minus 1 minus root 3i. Okay. So we have completed answering question number 11. Thank you for staying with me till the end. I am Nilanjana Sanyal. I am an online IB Math ESL and AGL level tutor, and I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services to my students. In case you are liking my explanation, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching my video. And please subscribe to my YouTube channel in case you have not subscribed to my channel till now. We meet again very soon where we'll be solving the last question of the same paper. Till then, bye.